Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. We're continuing to look at recursion and how we can use recursion to solve different problems. In particular, we're looking at the problems where we want to try different paths and our recursion calls itself more than once. And in this video and the next two, we're going to talk about some sort algorithms that apply a general approach called divide and conquer. Divide and conquer isn't just a good approach for winning a war, it's also a standard way of dealing with problems in computer science. The idea here is that when you have a problem that is too big for you to deal with, you divide it up into smaller problems, conquer those individual problems, and then put together your solution from those pieces. And so it turns out that a very good example of divide and conquer can be found in the area of sorting, and we're going to talk about two particular sorts. Now, both of these sorts have one thing in common. If we give them a big collection of data, a big array, like this, represented by this large box here, what we do is we somehow break it up into two smaller pieces. And we're going to break each of those into two smaller pieces, and then we're going to break each of those into two smaller pieces, so on, so on, so on, until we get down to individual elements. As a general rule, in the case of sorting, if you have an array of length 1, it's sorted. Okay? You can't guarantee that for 2 or 3 or 4, but once you get down to one element, that is a sorted array. So that's our base case there. Now the two sorts that we're going to talk about, the quick sort and the merge sort, are a little bit different in how they work and where they do their work. And it's worth discussing that a little bit, the differences between them, before we actually go and look at the algorithms themselves. So in both cases, we're splitting the array up into smaller and smaller pieces until we get down to individual elements. In the case of the merge sort, the splitting just does exactly that. It splits up the values and doesn't really try to optimize or to do any work on them other than just splitting it up. So it takes the big array and it breaks it into two halves, and then it takes each of those and breaks it into two halves without really moving anything around, without doing any real work on those two pieces until it gets all the way down to the bottom. And then it does its work as you come back up the call stack, and we'll look at how that works in the next video. So in the case of the merge sort, most of the work is happening not on the way down the call stack, it's happening on the way back up the call stack. The quick sort works in the opposite way. It actually does all of its work going down, so that by the time that you get done with this last box over here, everything is done, and the popping back up the call stack is just kind of a gratuitous effort at the end to get you back up to where you came from. But no real work happens as you return back up this. Now, this divide and conquer type of approach works not only for sorts. There are lots of different algorithms that use divide and conquer. We're going to talk about sorts here, though, because they are easy to understand and they make really good candidates. So in the next video, we'll talk about merge sort, and in the video after that, we'll look at a simple implementation of quicksort.